Hi, welcome back to the Xplore YouTube channel. So in this video, we will be looking at an essential data structure in Java, which is known as Hashmap. So let's begin. Now, Hashmap can be used in some specific cases, and I'll again state that in the coming few minutes. So Hashmap kind of contains values in the format of key and value pairs. Yes, they contain the value in the format of key and value pairs. Now, in this case, my key is always unique. Yes, my key is always unique. So what I can say is, in my hash map, I cannot have two keys with the same name. Yes, I cannot have two keys with the same name. But what about values? The values can be same or it can be duplicate as well. That never matters. What matters is the key is always unique. What if I give you a very small use case? Let's say I tell you that, hey, there is a classroom, right? This is nothing but a classroom. And there are some people in my classroom, some students in my classroom, and I kind of want to count the number of students whose name is Z, the number of students whose name is C, the number of students whose name is A, right? This is my use case. And again, this can vary. Up here, I know I have 1, 2, and 3 students I need to count. But what if I had to count, I don't know, 13 students? What if I had to count 200 students and then so on, right? So this can vary. This can vary, okay? Now, let's say in my classroom, I'm going to probably arrange some students. So let's say A sits here, right? And again, there is always a possibility that a person with the same name in the classroom exists multiple times, right? And we also have experienced this. So let's say this is A, right? So the other person might be A as well. And this guy might be A as well. This guy might be A as well. Let's say there's a girl G, right? She might be, this girl might be of the same name. Let's say there's C, 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 and then let's say we have Z, Z, and B. Now, the very first thing which might come to your mind is, hey, I will store this maybe in a linked list or an array list or an array, right? But let's assume you store this in an array for an instance, right? Or let's say in an array list for an instance. So what will you say? Hey, my array list will be containing all of these elements, right? In this case, we have A, Z, G, Z, Z, G, Z. I'm accessing the values like so. So then we have C, B, C. So that's C, B, C. Then we have A, C, A. Followed by GCA, right? GCA. So that's it, right? So my array list is containing these values. Now, again, the next step for you would be to simply go over each of these names. So you are firstly at Z, right? So at Z, you will say, okay, I'll count how many people are Z. So you start from the beginning, which is at the 0th index, and you go till the very end, which is at the n-1th index, right? Then you go over, hey, that's Z, that's 1 people, that's 2. Then I think so there's 2 Z's, right? If I'm not wrong. Yeah, there's 2 Z. So you say, hey, number of Z is 2. Okay. Now you come to C. Again, you go from 0th index to n-1th index. And you say, okay, C is that's 1, 2, 3, and 4, right? So that's 4. I'm going to verify from here. That's 1, 2, 3, and 4. Now what about A? Again, I will notice the pattern here. Again, I have to go from 0th to n-1th index, right? So 1, 2, 3, and 4. So that's 4 again. Again, I'll verify. That's 1, 2, 3, and then 4. So that's it. You might be saying, hey, that's good to go. But have you noticed for each name, I have to scan the entire classroom. Scan the entire classroom, right? And that's going to be an expensive operation. So for Z, you went through the entire thing. For C, again, you went through the entire thing. For A, again, you went through the entire thing 3 times. So if this is given, let's say 100 times, then you will be going through this entire thing 100 times, believe me. But that's not the way. That's not the way. You have to come up with an approach such that you scan the classroom once. Yes, you scan the classroom simply once. Once you do that, you say, for each one of these names, I will answer that in a big O of 1 time. Now, what does a big O of 1 time means? It basically means no time complexity. It's really quick, right? Example is, Let's say I have an array, elements are 5, 6, and 7, indices are 0, 1, 2. So if I say, hey, what is the element at the second index? And if this is the array, you say the element at second index is a of 2, right? So you got the element at the second index, which is 7. But what is the time complexity here? That's big of 1 time. I hope you can relate and interconnect. There's not much involved here. This is the same thing. It's going to take no time if you look at it as an overview. Okay, great. Now, how do I get to know in a single pass of the classroom that, hey, I want to get the answer for these, all of them, in a big O of 1 time? Well, here's the place where Hashmap will be used. Notice carefully, the Hashmap, again, as I've mentioned, contains key and let's say value pairs, right? So in this case, I will say my key will be the name of the student and my value will be the frequency of that name. Yes, the frequency of the name. How many times is this name appearing in my classroom? So let's say my classroom, or let's say my Hashmap name is classroom. Okay, now I'll demonstrate it as follows. So I'll go simply over here. Let's say I'm firstly at A. I'm using the red marker. So I'm at A. I'll say, is A in my classroom Hashmap? No, it's not there. So initialize A and say A is occurring once. Beautiful. Now I'm at Z. Is Z in my classroom? No. Initialize Z as 1. I'm at G. Is G in my classroom? No. Initialize G as 1. Again, I come over to Z. Is Z in my classroom? Yes, it's there. So what will I do? I'll simply increase its count from 1 to 2. It's that simple. So again, you come over to C. You see C is not there. So I'll quickly run over this. I hope you are getting the pattern. So B gets here, right? This is done. This is done. Now again, C's count will be 2. So I'll get rid of that and initialize this with 2. And this has been done. So A count also increases. C count also increases. A counts again increases. G count increases. C count increases. And then we have lastly A. So that becomes 4. So again, I'll update the final value here. In this case, A was having 4. G is having 2. So I'll do that. And then C is having 4 as well. So let's quickly do that with the comma, and B is occurring once itself. Now notice one thing, once we have the key and value pairs, if someone comes to me and tells me, hey, how many students with the name Z are occurring? So you simply refer the classroom Hashmap and say, okay, hey, Z is occurring how many times? 2 times. You got the answer in big O of 1 time, which is very, very fast, or one might say it's very, very efficient. Now, what about, I don't know, what about G? How many times is G occurring? So you say, hey, it's occurring twice. C, it's occurring 4 times, right? Then A is occurring 4 times. I don't know, like if you ask many number of times, I can tell it, right? What if I say, hey, how many times is J occurring? How many times is J occurring? So you know there is no key such as J. There's A, Z, G, C, and B. There's nothing as such J. So what will be your answer? 0. And again, there is always an operation which, so in this case, what you have to do is, you have to firstly check, is the key present in my classroom? If it's there, then search for how many times it's occurring. If it's not there, simply return 0, because if it's not there, then there's no student named as J, right? So I hope this is kind of giving you an idea or an overview of what an hash map is. So in the next video, we will probably look at few of the operations of the hash map and how to declare them. Meanwhile, feel free to like the video and subscribe to the channel as well. Thank you.